All right, pre-calc, we are going to do one more section here on 4.3. It's the third day, which is like the 15th day in a hybrid cycle. I'm not sure how that works. All right, so we got things for today to consider, right? We know that cosine, sine, that makes up the ordered pair. We're going to deal with that from the unit circle. All right, since we know that the ordered pair is made up of cosine and sine, we also know, remember the ka. If we're talking about the unit circle, what happens is the hypotenuse is the radius. So we're going to shorten that up just a little bit to deal with that. So as we look at our problems today, just think of the hypotenuse as the radius. So doing a little more translation here. Okay. Other piece of information that we have is dealing with the tangent is, remember, sine over cosine. So what's that mean in terms of your ordered pairs? That's going to be the y value over x. So cotangent is the reciprocal of that. And of course, we have some reciprocals listed below. Okay, so if the secant is 1 over cosine, cosine is the x, so it's 1 over x, same thing. So wherever we can use that as we take a look at some problems going forth here, then we'll definitely keep that in mind. All right, so let's take a look at what I actually need you to do with this. What do we want to do? We're going to find sine of theta. Okay, well, we know that has to do with a y value, so we're going to have to work our way through here. And here's what we have. We have cosine of 8 over 17. So what do we know about that so far? We know x equals 8, and the radius, right, is 17 as we deal with that idea. And the other thing we need to know is the terminal side of the angle is in the first quadrant. So that means whatever it is, it looks like this. All right. The next thing that we know is we have 8 on the x-axis, and the radius is 17. So what we need to find out is that y value, and that'll help fill everything in. Okay, so what are we going to do? It's a right triangle, so 17 squared minus 8 squared. That's going to give us the missing side squared. And what will happen here is we're going to end up with 15. Okay, because our end result here was what, 225, so square root of that gives us 15. All right, so that means we can go and answer the rest of it because we know the sine is still going to be over the radius or the hypotenuse, all right, thinking about so at this point. And what we're talking about is that y value, the opposite side, turned out to be 15. So it's 15. Ooh, I should put my theta in there. Sine of theta is going to be 15 over 17. So still using that right triangle idea, but also using our trig relationships to get through those. All right, so let's take a look at the next one. We want if secant of 2, secant of theta equals 2, and we're in the fourth quadrant, so we want to identify the 5 remaining trig functions. Okay, so here we go. We're in the fourth quadrant, so let's get this thing figured out. But let's figure out what's going on here as we think about it. Remember, cosine is going to be the adjacent over the hypotenuse or over the radius. So secant is going to be equal to the radius or the hypotenuse over the adjacent. So that's what we have right now. It's 2 over 1. And that means we're talking about an x value of 1 and a radius or a hypotenuse of 2. Okay, so that means we're going to deal with the square root of 3 right here. Certainly we can go through our right triangle, right? 2 squared minus 1 squared is going to give us that missing side. But we know it's 4 minus 1. So we're going to end up at 3, and we're going to take the square root of 3. All right, so here's kind of the strange thing about it is notice we're in the fourth quadrant. So what happens is we end up with negative. Okay, so we end up with negative. All right, so now we have the entire triangle figured out. So if we know that secant is 2 over 1, that means cosine, right? So things we still need is sine, cosine, tangent, and then we'll need cotangent. All right, so if secant was 2 over 1, cosine is 1 over 2, that means the sine is going to be the square root of 3 over 2. All right, but keep in mind that this is going to be negative, so negative. And that means tangent is going to be a negative square root of 3 over 1, or you can just leave it as negative square root of 3. That means cotangent, as we flip that over, right, negative 1 over the square root of 3, we're going to have to fix that one by rationalizing the denominator. So eventually we'll get there. And we had secant already, and we had answered. So what else we need? Oh, we need the inverse of sine, right? We need cosecant of theta. So it's going to start off as the reciprocal. So 2 over square root of negative 3. So we're going to fix that by multiplying by the square root of 3. So 2 root 3 over 3, and make sure it is negative as we deal with that. Okay, so just using one function to kind of fix all the other ones as we work through. So what we need to get used to is, as we look at these, the hypotenuse is now the radius. So anytime we have that, right, we can say that's r. So this must be r as well. So trying to put it, the circular function with the triangles, putting all those pieces together. All right, I think we got another one here for you to try. But you know what, there's some homework attached. So let's kind of walk through just to make sure everybody's okay here. We're in quadrant 2. So whatever it is, I'm just going to draw a right triangle over here in quadrant 2. So I got that part taken care of. Next thing we know is cosecant. All right, well, that means we're talking about the hypotenuse over top of the opposite, right? Because that's the inverse of the sine function, and sine is opposite over hypotenuse. So we're kind of working backwards here. And remember, the hypotenuse is actually the radius. So this is square root of 65 is the radius. Right? And as we look at it, what we're trying to find out is the opposite is 4. Remember, that's a y value. So what we're looking for is an x value, and keep in mind, since we went to the left, it's going to be negative. So as we try and fill everything in here. So let's first find out this missing value. Square root of 65, we need to square that, minus 4 squared. That's going to give us x. All right, morning announcements here. So let me pause. All right, trying to get some work done here in the morning, and all the interruptions happen here. All right, so square root of 65 squared, that's 65 minus 16. That's going to give us x squared. So we're going to be down to, what, 49 x squared. So we're going to take the square root. All right, so x turns out to be 7, but keep in mind, we said that this is going to be to the left. So that means we're talking about negative 7 is going to be that x value. And based on, remember the angles here, so this is going to be adjacent. And this is our opposite. And of course, that's our hypotenuse. So what are we after? I lost track. Oh, cosine. All right, so so cosine of theta, the adjacent side, well, that's negative 7 over the hypotenuse. Oh my goodness. Will this problem ever end? Here we go, root 65, root 65. All right, it's a little formality from here because 7 and 65, they don't have anything in common. All right, so cosine of theta, right? So we started with 65 over 4, identifying the hypotenuse and opposite. And then we had to work our way back. All right, so we used the idea of sine to figure out what those things are. Flipped it around so we can put everything into our graph. Found out the third missing side so we can find out that x value, and then we're able to plug that back in. Okay, so all of half of the homework stuff is going to follow that pattern. So hopefully we did okay with that for you. So let's take a look at the next one, just identifying positive, negative, 0, undefined. And I think most of you are comfortable in degrees. So let's go ahead and say this is, what, 150 degrees. Okay, so if we had cosine of 150 degrees, remember this, all students take calculus. This is talking about where things are positive. Okay, so if I'm in the second quadrant, right, and I'm talking about cosine, well, this says sine, so that means I must be negative. All right, so that's how simple that goes. I hope that's simple. All right, let's figure out where this one is. 180 degrees is way over here. Okay, so what's the ordered pair? The ordered pair here is going to be -1 paired with 0. Tangent is going to be the y value over the x value. So that means I have a 0 over top of -1, so that's going to be 0. Sine of 2 pi, well, that's 360 degrees, right? So that means we're going to end up right back where we were. Coterminal was 0. So what's the ordered pair? Well, that's 1, 0. And what we're after here is the idea of, remember, it's cosine and then sine. So sine is the second number, so sine is 0 again. And I tried to make sure some of these zeros and fine and stuff like that falls in here. That way we're kind of used to that idea. All right, so let's see, we're at negative 60 degrees. So we're gonna go ahead and make that 300 degrees. So that puts us in which quadrant? We're in 300, so that's the fourth quadrant. Okay, and secant is going to then be, goes along with the inverse of cosine, right? So we're thinking about the cosine in the fourth quadrant, and look at that, it should be positive. Okay, so we're not trying to figure out exactly what it is, we're just trying to figure out positive, negative, zero, undefined. All right, here we go, cosecant. Remember that is 1 over sine, so that's 1 over the y value. So we're going to try and get that idea straightened out first, and then let's see where we're at. 0 degrees, so we had that one up here, so 1 over 0. Okay, so the y value is 0, 1 over 0, so this is undefined. And our last one, we're dealing with negative. So keep in mind, first, quick translation, 225, it's negative. We're going to add 360. So we're at 135 degrees. That puts us in quadrant 2. And if I'm in quadrant 2, this is a sine function. Okay, all students, so it's positive because students stands for sine. All right, so that should give you a model of each one. Okay, whether we're trying to draw our triangles, figure out the missing side, and then write in our trig function. Keep in mind, based on what we solved, its location may make it negative, right? We know the square root of 49 could be positive or negative, but in this case, we're truly making it negative because of its location. So that's why it is helpful to have that script. All right, so it looks like we get a little bit of both, right? So it kind of models exactly the way we did it. So these go along with the first couple that we did. And then this is going to be that all students take calculus. So you might even want to put it in this way. All students take calculus. Just to figure out what quadrant we're in based on sine and cosine and a tangent in there. So we should be good. Oh, this one ends up on an axis, so we're good. All right, we'll work on it in class to clarify any questions and continue from there.